Hi everyone. I wanted to take just a minute to do a couple of examples off of this page here, the factoring putting it all together page. This is the best page, I would say, for making sure that you're ready for today's quiz. Okay, so I already posted an answer key to this page, but I thought I'd pick just kind of one of each type of problem and run through it right here. I'm going to start with problem number 1. So problem number 1 looks like this, 2x squared minus 8. And from looking at it, from the beginning, it doesn't look like there's a whole lot we can do with this one. But what I encourage you to do is always, always, always start by looking for a greatest common factor, okay, in every problem that you do. There's some problems that you can't do anything with them unless you find a GCF, and then there's others where you could do something even without it, but pulling out the GCF makes it easier, okay? So either way, you're in the best position if you look for a greatest common factor to begin with. So I'm going to say that each one of these things can be divided by 2, and when I divide them by 2, this first one would be an x squared, and the second one would be a 4. Okay, and remember the whole idea here is that when I multiply this 2 back through, it would turn back into this. So that's how you can always check to make sure you pulled out the GCF correctly. Okay, then I'm looking at what's left over here, x squared minus 4, and that's a difference of 2 squares. That was one of the special cases that we talked about. Anytime you have subtraction of 2 perfect squares, you can use the difference of 2 squares factoring, and that's where I would say, well, x squared becomes like x and x. 4 becomes 2 and 2. Okay, that's what makes them perfect squares, because I can split it into 2 exact equal pieces. One gets a plus and one gets a minus, and that's how it always works for difference of 2 squares. Okay, we talked about all the reasons why that's true on Friday, but really you just need to know that every time you see this, that's what it's going to look like. And then just make sure you bring down the 2, and then this thing right here would be your final answer. If you multiplied that all back together, it would turn back into 2x squared minus 8. Okay. All right, next up here is number 5. Number 5 is a trinomial, 2x squared plus 12x minus 80. And just like I mentioned before, the very first thing I would do is look for that greatest common factor. And out of all 3 of these, I can pull out a 2. No x's, because that 80 doesn't have an x. So then this would become x squared plus 6x minus 40. And then this is a trinomial. It has 1, 2, 3 pieces. It's not a difference of 2 squares. It's a trinomial. And it's a trinomial where I don't have anything here in front of the x squared. So I don't have to do that longer, more complicated process. This is where I can just set up my parentheses and say, here's an x, here's an x. Okay, so it's sort of a shortcut when you run into one of these, where you don't have to do the multiplying the a by the c or anything like that. Looking at this sign here, I know I want to make a negative 40, so that means I'm going to need a positive number and a negative number. And then I'm looking for things that multiply to make 40, but add to make 6. Okay? And if you needed to, you could go off to the side and make a list of all the ways that you can multiply to 40. And remember, when I say add to 6, you have to kind of take that with a grain of salt, because you're really doing a positive and a negative. So for 40, I would say 10 and 4 are going to work for us. We want to make sure that we place them so that they make a positive 6. So positive 10, negative 4 would work. Bring down your 2 in front, and here's your final answer. Next up, let's look at number 7. Number 7 says 8n squared minus 18. Just like before, I'm going to pull out the GCF. 8 and 18, the only thing they have in common is a 2. And so that will leave me with a 4n squared and minus 9. And then I want to look at this and ask myself what kind of factoring that is. Well, it's not a trinomial, right? It doesn't have 3 pieces. It has 2. So really the only thing we've done factoring wise with two pieces is difference of two squares. So I check and I look and I say, is this a perfect square? Yes, it sure is. Okay, is this a perfect square? Yep, it is. Is it subtraction in the middle? Yes. So as soon as I know that, I can split this up and I can say, all right, we're going to have 2n and 2n. That's how I would make 4n squared. Remember, I'm splitting it into two equal parts. 9 would be 3 times 3. And then to make subtraction, I'm going to have 1 positive, 1 negative. Every single time, that's how difference of two squares works. Okay? Really, it's the square root of this and the square root of that. One with a plus, one with a minus. And then don't forget to drag down that 2 that was your GCF. Okay, you don't want to lose that. And so there's your final answer on that one. So moving on, we're looking at number 8 now. And just like every other one, the first thing I would look for is what common factor do they all share. They all share a 7, so I'm going to pull out a 7, and I end up with 2x squared. So I'm dividing everything by 7. This would be a 1x, and then minus a 3. Okay. Now, this is a trinomial, 1, 2, 3 pieces. But notice this one has a number in front of x squared. So I can't just do x times x, okay? We did one a few minutes ago. I can't do this. And in fact, I'm going to erase that so you don't get confused. But normally with a trinomial, we start out like this. That 2x squared is going to throw things off here. Okay, so I'm going to get rid of that guy. When you have a trinomial that has a leading coefficient, this number here, we're going to multiply the 2 times the negative 3, and we get negative 6. And then I'm looking for numbers that multiply to that negative 6 and add to make that middle term of positive 1. Okay. Well, there's not very many ways to multiply to 6. I'm going to use 2 and 3 because if I make the 2 negative, then negative 2 plus positive 3 would give me positive 1. Okay. So now what I'm doing is I'm taking this expression and just rewriting it, but I'm going to take this 1x and replace it with a negative 2 and a positive 3x. So here's what that's going to look like. I'm going to leave my 7 out front here. If you want to ditch your 7 altogether here just to make it look less confusing, that's okay, as long as you remember to pull it back down at the bottom. And so then I'm going to write this as 2x squared minus 2x plus 3x minus 3. So this is just equivalent. This right here is an equivalent expression to this. All I did was separate the 1 into a negative 2 and a positive 3. But it's still equal to that. And then I'm going to take these two pieces and group them together and these two pieces and group them together. And I'm going to pull a greatest common factor out of each one. Okay? So out of 2x squared and 2x, they share a 2 and an x. If I take a 2x out of a 2x squared, I'm left with just x. And remember, you can check yourself by saying, do these two multiplied together give me back 2x squared? They sure do. And then if I take a 2x out of a minus 2x, remember that you will still have a minus 1 there. Because again, you want to be able to multiply this back together and have it turn back into this. Okay? And then, same thing over here. With this second group, I'm looking at what they have in common. They have a 3, a positive 3. And then if I take a 3 out of 3x, I'm left with just x. And if I take a 3 out of negative 3, I'm left with just a minus 1. Okay? And all of this would still have that 7 hanging around down in front. So like I said, if that 7 confuses you, you can wait till the end and just stick it back in, but you really have to make sure that you don't forget it. Okay, then as far as making my factors go, the first thing I look for is my twin parentheses. If you did this right, you should always get parentheses that match here. This is an x minus 1. My other parenthesis comes from the pieces that are left over on the outside. So that would be 2x plus 3. And then, like I've been harping on you this whole time, we're going to bring down this and put that in front of my answer. Okay? And so this right here would end up being my final answer on this one. These ones are a little more complex when they have that leading coefficient. Okay, take a few more steps. All right, let's take a look at number 10 now. Number 10, let's pull out our greatest common factor. What do they all share in common? And they do share a 2, but make sure that you're also looking for any x's that they share in common. These ones all have at least one x that I could take out. So that would leave me with just a 9 when I take that out of 18. And again, 2x times 9 would multiply back together to make 18. Okay. 2 times 6 makes 12, and then I'm pulling out an x, so I'd have 1x left there. And then if I take 2x out of 2x cubed, that'll leave me with just an x squared. Now, I've been getting a lot of questions on this one in particular, because this thing comes out looking kind of funky. But if you read this backwards, if you read it starting at the x squared and backwards, it would look more normal. So normally I don't advocate for this. Normally I don't like to rewrite these things. I just like to keep them in the same order. But for this one, because it's all addition, I'm going to take that thing on the inside and just rewrite it in a way that we're more used to. X squared plus 6x plus 9. And this one is not impossible to factor the other way, but this is just more like what we're used to. So again, looking at a trinomial here, no leading coefficient. I don't have to worry about making some other type of x squared. So these are the easy ones. These are the ones where you can just go x and x. Okay. Now, if you really wanted to, you could go, okay, there's a 1 here. So 1 times 9 is 9, and what multiplies to 9 adds to 6, and split apart the middle and do the greatest common factor and all that stuff. You just don't have to with these, because I can say to myself, well, this is positive, so I know my two signs have to match. This is positive, so if I need to add and come out positive, that must be with 2 pluses. Okay, positive times positive. And now I want to multiply to 9 and add to 6. Well, that's going to be with a 3 and a 3. And then drag my 2x down in front. Now, notice how those parentheses came out the same. That means that this is one that if you had caught it, this is a perfect square, this is a perfect square. This middle term works out so that this is a perfect square trinomial. And this is one of the ones that we could have taken our little shortcut on that we talked about the other day. But notice it really was not that hard for us to just do this the normal way, and then I didn't have to worry about a different method. Okay, so that's why I kept saying I don't know that I would worry about that shortcut as another method, because this way works just fine. Okay? All right, another one that I've been getting a lot of questions on is number 11. 2x minus 2xy squared. Okay? I would start still with a GCF, and what they have in common is a 2x. So I'm going to say if I take 2x out of each term here, if I take 2x out of 2x, remember I would be left with a 1, because you want to be able to multiply back together to equal that 2x. Minus, and then if I take the 2x here, if I divide this by 2x, which is really what I'm doing to each piece, dividing by 2x, I'm left with a y squared. So now the question is, what else can be done with this thing? Okay, this is one, by the way, that if you didn't pull out the right common factor, if you didn't get a big enough common factor, you wouldn't be able to go any farther here. Okay, but you need to be able to go farther because there's something else that can be done. So that's why I've been emphasizing really making sure that you pull everything out that you can, because sometimes it stops you from being able to go any farther. Okay, well, this isn't a trinomial, right? It doesn't have 3 pieces. It only has 2. 1, 2. It's a subtraction, so the first thing I'd be thinking of is this a difference of 2 squares? Well, 1 is a perfect square, because 1 squared makes 1. And y squared is a perfect square, because y squared makes y squared. So I can go like this. Parenthesis, parenthesis. This is going to be 1 plus y. This is going to be 1 minus y. Difference of 2 squares factoring right there. Okay, the 1 splits up into 1 times 1. The y squared splits up into y times y. The positive negative makes that minus sign. And the positive negative also makes it so that my middle term drops out of there. Okay, and then of course we want to bring down that 2x as part of our final answer as well. And then this would be our final answer. All right, let's take a look at number 13. This is a trinomial, and I'm again looking for a greatest common factor here. So I look at this and I say I can pull a 3 out of everything. Can't pull any A's because the 9 doesn't have an A. And that's going to leave me with 8A squared minus 10A plus 3. Okay. And just a quick check in your head, make sure that if you were to distribute this 3 back in there, it would turn back into this original problem. And it does. So now I'm left with a trinomial, 3 pieces. It does have a leading coefficient. I've got that 8 there to deal with. So this isn't one of the quick and easy, simple, just double parentheses ones. This is one where I'm going to have to say 8 times 3 is 24. I want to multiply to make the 24, add to make this negative 10 in the middle. So ways I can multiply to 24 that would add to 10 would be 6 and 4. If you needed to, you can make a little list, all the ways that you can multiply to 24. And then I'm just noticing that I want to make a negative 10 in the middle here. So I would really like these both to be negative because that will get me a positive 24 here, but a negative 10 here. So now step 2 is to take this thing and rewrite it, but in place of that negative 10A, I'm going to put in a negative 6A and a negative 4A. Okay, so that if I were to put that back together, it would just give me back this. Now, I'm going to look for a GCF here and a GCF here. Okay. So out of 8A squared and 6A, I can pull a 2 and an A. And then let's see if I take 2 out of 8, that would leave me with a 4A minus, and 2A out of 6A would be 3. Now, when I look at this next pair, the negative 4A and the positive 3, I don't have anything I can take out, right? There's nothing that they have in common. So normally what I would do is I would just say plus 1. Okay, right here I would say plus 1 and then leave this in parentheses like I'm pulling out a 1, which I know is a little weird. But notice that this is backwards sign-wise from what I want it to be. I want it to be a 4A minus 3 to match this. So knowing that, what I'm going to do instead of pulling out a positive 1 is I'm going to say I'm taking out a negative 1 as a GCF. And I knew to do that because I knew that I wanted it to end up matching this parenthesis here. So when I divide by negative 1, my negative 4A now becomes a 4A. And when I divide 3 by negative 1, it now becomes a negative 3. And then I have this parenthesis matching this one, okay, which is what you want to have happen. Okay. I'm going to talk about how we could have avoided that in just a second, but let's go ahead and write down our parentheses here. So my first parenthesis would be the 4A minus 3, the parenthesis that matches. My second parenthesis would be 2A minus 1. Okay, and then just don't forget we left our 3 behind back here. We need to put our 3 back in our final answer, and this is where we ended up. Now, that weirdness with the negative 1 could have been avoided. Okay, what we did works out just fine, but it could have been avoided. Back here when I place the negative 6 and negative 4, it doesn't matter which order you put them in. It's always going to work out. You're always going to get the right answer either way. You might just run into something like this where you have to factor out like a negative 1 or something weird. If I had switched these two, if I had taken these two and flip-flopped them, then I would have been pairing up the 4 with the 8 and the 6 with the 3. And those numbers are kind of a little more compatible that way. So when you place these numbers here in the middle, you can choose which way you put them down there. So put them down in a way that makes sense in terms of what you're going to be pulling out for a GCF. Okay? I mean, don't spend a ton of time thinking about it. Really, if you just throw them down there, it's going to work one way or another. But to avoid weird things like this, try to put numbers together that match, okay, that you're going to be able to pull a GCF from more easily. Okay, I'm going to hit one more problem. All right, last one I'm looking at here is number 15. And in number 15, I have seen some students just dive right in and say, okay, I'm going to go 3 times 147. All right, and that's okay. You can do that. But it just comes out to be kind of a giant number to be working with. If you want to avoid that, this is one where a GCF will take care of that for you. And you may be thinking like, yeah, but I don't know what goes into 147 to know what I can pull out as a common factor. There's really only one thing that would work here. If I'm looking for something that all 3 of these have in common, the only thing I can pull out of this would be a 3. So check and see if 147 divides by 3, and it does. Okay, so I can pull a 3 out as a greatest common factor, and I'd be left with x squared. 42 divided by 3 is 14, so that'd be minus 14x. And then 147 divided by 3 comes out to be 49. Okay. Okay, and then I'm looking at a trinomial, 1, 2, 3. No leading coefficient, which is always nice, right? Because when there's no leading coefficient, then I can just say x and x. And then just think about my signs and all of that. I want this to multiply to be positive, but add to be negative. And so the way that's going to work is if you have a minus and a minus, right? And then I want to multiply to 49, but add to 14. And so what jumps out at me right away as multiplying to 49 would be 7 and 7. And then those would also add to give you that negative 14. And then just bring down your 3. So this one would have worked if you had started it a different way, but it would have taken you a lot more steps to get there. Okay? This is really just my answer. Okay?